All right, this video is going to be going over section 9.3, which is about solving by taking square roots. So we're going to be solving quadratic equations that are able to be solved by simply taking the square root of both sides at some point in time. So let's get going here. Got all sorts of fun stuff going on. All right, so this is the front side of the notes that we got for 9.3. We're going to not go through these review problems and get right to our new types of problems, the solving by square root problems. So one thing I'd like you to put on the top here to kind of signify what we are doing, or how we expect our answers to be, is we want our answers to all be exact, meaning we're not going to have any decimals in our answers in these equations. Okay, so we're going to have exact answers only. We'll talk about what that's going to entail in a second here. So if you look at the first problem here, x squared equals 81, the first thing we are going to do is notice that the x squared is all by itself, which means we are ready to take the square root right now in order to solve this problem. So we take the square root because the square root and the x squared, that exponent of 2, will cancel out. So what we're left with then is just x on the left side. When you take the square root of 81, square root of 81 is 9. But what we want to remember when we're taking the square roots, and this is something else I'm going to put up on top here, is that when you take the square root, we have to remember that if we're solving, we can get both positive and negative answers. So in other words, in the original equation, not only would 9 have worked, but negative 9 would also work. Because if you square either one of those, you'd get 81. Every time we take the square root, we're going to be putting positive, negative in front of our answer. Okay, so get used to doing this. We're going to have two answers for a lot of these problems. The next problem over here, x squared equals 40. This x squared is all by itself, so we're ready to take the square root right now. Now, 40 is not a perfect square, okay? Perfect squares, it's not a bad idea to have this somewhere as well, because we're going to be using these a lot on this sheet. Perfect squares are numbers like 1, 4, 9, 16, 25, 36. I'm just going to go up to 100 here. Let's see, here we got 1 squared, 2, 3, 4, 5, 6, 7, 8, 9, 100. Those are the first 10 perfect squares, and obviously that goes on forever. 40 is not in that list, so we're not going to get a answer right away here. What we need to do is simplify the square root of 40. Okay, so when we say exact answers only, that means we need to simplify our radicals. Let's see what that looks like. When you simplify a radical, you're going to split it into two separate radicals. In the first one, you want to put a perfect square. Okay, so what you need to think of is, in the number 40, what is a number in this list that is a factor of 40? Well, 4 goes into 40. Okay, and you want to get the biggest one possible, but 4 is the only number in that list right now that goes into 40. So we want to put 4 in that first radical. What goes in the other radical is what you would multiply 4 by to get 40. So that would be 10. Okay, so if I were to multiply these together to get the square root of 40, which is why I separated the square root of 40 into these two radicals. The reason why we do that is this first one, since we put a perfect square there, we can simplify. The square root of 4 is 2. Okay, so we have x equals, bring that positive negative down, square root of 4 becomes 2, and then we just drop that square root of 10 down. That is the exact answer to what the square root of 40 is. I'm going to take the square root right away in this next problem. X is going to equal positive negative. Okay, 75 is not a perfect square. So I'm going to separate this up. Look back up here. Which number goes into 75? 25 does. So 25 is the number we want there. We would multiply 25 by 3 to get 75. So I bring that positive negative down. The square root of 25 is 5. And then we just drop that square root of 3 down. There's our answer. Actually, our two answers. Positive 5 square roots of 3, negative 5 square roots of 3 to that equation. All right, before we can take the square root, we need to make sure that the x squared, or whatever is being squared, is by itself. So the first step in this next problem is to divide by 25. Okay, that'll get rid of that 25 out in front of that x squared, and I have x squared equals 16/25. Now we're ready to take the square root of both sides. Okay. The square root of 16/25, fortunately, both of those numbers are perfect squares, so we can easily find the square root of 16/25. First, we're going to put our positive negative, because we took the square root. Now we just take the square root of the numerator and the square root of the denominator. So the square root of the numerator is 4, and the square root of the denominator is 5. That would be our final answer. So we're going to keep things exact. Leave things as fractions. You do not want to find out what this is as a decimal. You want to leave it as 16/25 so that you can take the square root of it easily. Next one is going to be very similar. Divide by 9 first. So we're going to have 25/9 on the right side here. Then we're going to take the square root. Okay, so don't forget positive, negative. Both of those are perfect squares. Square root of 25 is 5. Square root of 9 is 3. Two answers are positive and negative. 5/3, 5/3. Okay, now we get a little different here, because notice it's not x squared now. Now it's some sort of binomial squared. I got good news for you here. You do not need to worry about foiling these out. You don't have to write that out as x minus 2, x minus 2. You can't bring that 2 in like that because of the subtraction on the inside, so don't do that. You are ready right now to take the square root, because that will just cancel out that 2 right there, and all you're left with on the left side is x minus 2. Okay, so whatever was on the inside of that parentheses is what you're left with. The square root of 9, hey, that's a nice perfect square, so the square root of 9 is just 3. But don't forget, we have positive and negative. Okay, that's important. You should be getting two answers to almost all of these problems. All right, so what we have now is two separate equations that we need to solve. I'm going to come this way because I don't have really that much room going down. First equation is going to be that x minus 2 equal to negative 3. And then the second equation is going to be that x minus 2 equal to the positive 3. So I just took that positive negative 3 and I separated it and put 1 in each of the equations. All right, now we solve each of these separately. I'm going to add 2 to both sides here. So we're going to get x equals negative 1. Add 2 to both sides here. And we're going to get x equals 5. Those are our two answers. You can write it as two separate statements like that. You could write it as one statement like this, put a comma, or put the word or in between. Either works. Okay. If you're going to do it like this, though, make sure you don't put those in parentheses. Don't do that, because it's not a point. It's two separate x values. If anytime you need to pause the video, feel free to. I'm going kind of fast here. All right. The next problem, we are ready to take the square root right here. The issue here is, though, 20, again, that's not a perfect square, so we don't want to pull out our calculators and find the decimal. We want to leave this exact. So on the left side, I'm left with x plus 3, because that cancels out with the squared. On the right side, we're going to do positive, negative. Let's separate 20. A value that goes into 20 that's a perfect square is 4. And then the other factor would be a 5. So what this is then on the right side there is positive or negative 2 square roots of 5, because the square root of 4 just became that 2. Now, we do not need to set up two separate equations here. We're going to just leave this as one nice little package where I'm going to now subtract 3 from both sides. All right, but here's what it's going to look like when I do that. I'm just going to write that negative 3. Where I really like to put it is in front of that plus or minus. So here's what your final answer is going to look like. When you subtract that 3 from both sides, just put it in front of the plus or minus like that. Okay? And this is how we're going to leave our answer. -3 plus or minus 2 square roots of 5. Okay? What I want you to understand, though, is it really represents two different answers. One answer is -3 plus 2 square roots of 5. The other answer is -3 minus 2 square roots of 5. Those are the actual answers to this problem, but we just kind of leave it like this because it's easy to write it that way. And the next one here, when we take the square root, we have 3x plus 1 because those cancel out. This time 49 is a perfect square. 7. Don't forget your positive and negative. Okay, so now since this is a number that we're going to be able to actually subtract 1 and then divide by 3 here in a second, let's set up two different equations. We have 3x plus 1 equals -7, or 3x plus 1 equals +7. We're going to solve each of those equations. So we're going to subtract 1 here, get -8, and then divide by 3, and get -8/3. Again, leave it as a fraction. Okay, over here we're going to subtract 1 and get 6. We're going to divide by 3 and then get 2. And those are our two answers. I'm just going to write x equals -8/3 or 2. All right, take one more step up here. We are going to oh, actually, we're not yet. Sorry, we're looking at this one here first. So we're going to take the square root to start here. Square root of both sides. So on the left, we're left with 2x plus 3. And on the right, we are left with, okay, square root of 18, not a perfect square. So we want to separate this. Perfect square that goes into 18, if I look up here, okay, perfect square that goes into 18 looks like 9 does. So we come back down here, put a 9. What would you multiply 9 by to get 18? 2. So that becomes positive -3. Square root of 9 is 3. Square root of 2. All right, then the next thing we're going to do is subtract that 3 over. So it's going to look like this. -3. So I just subtracted 3 and I put it in front like we did right here, where we put it in front. -3 plus or minus 3 square roots of 2. And then the last thing that we're going to do is we're going to divide by 2. We're just going to leave our answer like that. -3 plus or minus 3 square roots of 2 over 2. That's going to be our final answer. That is an exact answer, not worrying about the decimals. All right, last one here. We're actually going to do this one I'm going to change this problem here a little bit. I'm going to have you change this to a, get rid of that negative. Change that to a positive 32. Change that to a positive 32. All right, so I'm just going to actually rewrite this problem over here. 2 times 5x minus 2 quantity squared equals 32. I'm just going to rewrite the problem. All right, now you got to be careful. You can't take the square root yet because there's that 2 out in front. So what you want to do is get rid of that 2 first. You cannot distribute it in, okay, because that would go against our order of operations since there's that 2 right there. So what we're going to do instead, it's actually pretty easy here. This is multiplication. So what we can do is divide by 2. Just got to do it to both sides. So that leaves us with the equation 5x minus 2, it's still being squared, equals 16. Now we can take the square root. Okay, the square root of 16 is, hold on, let's slow down here. On the left, we're going to have 5x minus 2. The square root of 16 is 4, but once again, don't forget that positive or negative. Okay, you're going to have that in every single problem here. All right, Now we have, because I'm going to be able to actually combine these things because there's no radical over there. So what I'm going to do is write this as two separate, I'm going to keep going underneath here, two separate equations. 5x minus 2 equals negative 4, or 5x minus 2 equals positive 4. Okay, so first thing I'm going to do is add that 2 to both sides. I don't really need to show that. We're just going to add 2 to both sides in this one here. Negative 4 plus 2 would be negative 2. And then I'm going to divide by 5. So negative 2 fifths. Over here, we're going to add 2. We get 6. And I'm going to divide by 5. 6 over 5. 6 fifths. So those are our two answers right there. And again, you could just leave it like this if you want to just circle both of those. That's fine too, instead of putting it together in one x equals thing. Right. Okay, one more thing I'd like to talk about in this problem is what if it were negative? Okay, what if it were negative? So I guess I'm just going to rewrite what the original problem was. What if that 32 over here was negative? All right. And it doesn't matter, this doesn't have to be a problem with that 2 there or not. That doesn't matter. What matters is that there's a negative right there. This is kind of an important thing. So the first thing you'd have to do here is get rid of the 2. So we're going to divide both sides by 2 again and give yourselves that negative 16 right there. Okay, now here's where things get goofy. If you're going to take the square root of both sides, okay, to cancel that 2 out, what you need to know is that you cannot take the square root of a negative. The square root of a negative does not exist. Okay? So, it does not exist in the real numbers, which is what we're dealing with right now. So there is no real solution here. There's no real solution, or we could do that empty set symbol as well. Okay? On your worksheet, anytime you're going to take the square root of a negative, you can just say, well, there's not going to be a real solution, and write either one of those. Either one of those is okay. All right. What I want you to notice is here is I put the answers for the worksheet right down here, that 9.3a worksheet. There's two problems where you're going to end up having no solution. They're the last two problems. What you can do is ignore these answers that I have here, and just know that both of those answers are no real solution. Okay, in 8 and 9, you will end up taking the square root of a negative at some point. So know that you don't have to worry about the imaginary number thing. That's something that we'll talk about at some point in time, but we're not going to worry about that right now. You can just say that there are no real solutions to problems 8 and 9. But all the rest of these problems here, or all the rest of these answers, are the correct answers for the problems that you have on your 9-question worksheet for 9.3a. If you got any questions, shoot me an email or post them on Classroom so that I can answer it for everybody. Like I said, if you got any questions, please don't hesitate to let me know, and we'll get those answered right away. But you should be able to now get through that worksheet.